let's see where we're at. Got a histogram. Yeah, let's draw the actual tick values. Up at the top. So this is the ticks. Alright. That's the value that we want to draw. Alright, so we want to draw text, right? Like mu draw text or something. Micro UI. Context font. Yeah, because it's like, it's a different thing, right? It's not like an element. Mu font, I think it's just mu context font. I think it's carrying around micro UI. Let's see. Mu context CTX. It's that. Well, yeah, and what is it? There it is. Yeah, so it's got these callbacks, and then it's got the actual font. Does it have a font? Mu font. No? Oh, it's in the style. It's a style font. Str, lang, okay, 1, 2, 3, 4. 4. Position. Well, we kind of have this tick rect. Let's just use x tick rect y. I mean, can we just like bundle it like that? Color. Mu color. Well, actually, we'll just use one of those. X is color. Okay, apparently we can't bundle it this way. Mu vec2. Yeah, that works. Okay, so let's see. Where is this 1, 2, 3, 4? There. Yeah, that kind of makes sense. So it's drawing it at the top left there. Yeah. Which is essentially what we want. Except we need to align it to the correct place. And we need to draw the actual value rather than 1, 2, 3, 4. Now, since we have this mu context thing, we don't actually need font height. We can just work that out like here, essentially. Int font height is mu ctx. Oh my god. Text height. Mu ctx style font. Like that, and then we can just go in. Yeah, so we don't actually need this. There we go. So now it's easier, a bit easier to use. Let's see if this works. Yep. Okay, what are we looking for here? let's format the string. Actually, does it copy the string? Well, that's vec2, yeah. Draw text. Okay. Mu rect, check clip. If lang is less than push command, mu text. Okay, so it's not passing the string. Oh, mem copy, there it is. So it does copy the string. Okay, so we don't need to worry about keeping this around. We have temp memory and stuff, so I mean we can even get another one here. Go on. It's like stir builder, scratch. We have like we're passing in scratch, yeah. String builder scratch, format, tick value, string, tick value str. So this is putter, this is lang. Right. And length. Cast int. Okay, so now these are correct values. Hello, chatter. Need to align them. So this is the top left. Okay. New vec2 top left is that. Let's move it out. No, I guess position. So start at top left. Now position. I mean, I guess we can just move it like this. Tick rect y height. Oh, well, minus. Stop that. Is it being used? Yes. Okay, well. So tick rect. So that is position 1388, and tick rect is 1389. Oh yeah, tick rect, right? Tick rect is just the tick line. That's very small. Oh god, no, we don't want to quit. So let's take a look at this. So that's the tick rect, and that's the center. We're going to move it up by half of text height. Half up might be minus font height. Yes, something like that. And to the left. To the left by, well, it's the width of the largest string. which is, well, in this case we know what that is, right? It's 5 characters. It's 5 characters. Which I mean, we can get that font height int, font share width is mu ctx text width style. And what are you supposed to call it with? Just that. E.g. tick-rect minus 5 times font share width. So it's not callable with that. So what is it? It's lang. Well, yeah. Okay, well, I mean, it is aligned to the top of the tick. Kind of left aligned though. There is 0. So we are drawing 0. But it's like, it's clipped because of this. Yeah, maybe skip the 0, just like it's not that useful. Start at 10,000. Yeah. I mean, I guess we could align it to the middle. So it's tick-rect y plus, so to go down, tick-rect height divided by 2 and then subtract half. Yeah, which is like more to the center. Yeah, I mean, that's fine. Now the colors, we need to sort out the colors. New color. Is that not? Somewhere in here is the default style. Like here. Okay, so that's text, border, window background. Well, how about we just make that a 0? Yeah, pitch black. Border. Do we even see borders here? Well, that's a border. Which we don't really need, honestly, these borders. Text, button, buttons could be darker. I don't know, let's just try different colors, whatever. It's very dark. It's very dark. Maybe like 5 here. No, it's for 5 and 0, that's not a lot of difference. Oh, 10. Yeah, also not. Okay, buttons 25, like 30. Well, 30, that's not gonna. 40. Yeah. Yeah. base hover, base focus, scroll thumb. Oh, how's the scroll bar doing? Yeah, the scroll bar chord contrast is also kind of weird, actually. Scroll base. Like, you'd think the base should be dark and the thumb should be light. Perhaps. But that's how it normally works, right? Like here, the base is dark. Even darker than that. What's the background? 10, what's it, 20, 50. Yeah, that's fine. Now, axis color should presumably just be the same as the text color. Axis color is mu style colors mu color text. Like, is that how it is? Well, mu context. I mean, that is very bright. That is very bright, so maybe not. It's not that dark though. 150. Yeah, that's fine. Grid color. 100? I mean, that's the same as the histogram color though. Well, let's see. Yeah, grid color should presumably be darker. I mean, I don't know, 75. Darker. 50. Yeah, I mean, that seems okay. Seems comprehensible. Now, when I create these panels, maybe we just don't need frames on any of the panels. Yeah, like that. Why not? Yeah. Okay, so we've got ticks arranged on the Y. On the X we don't really need much. What we do need though is to sort the histogram. Where am I even iterating? Here? Yes. So right here is where the iteration is happening. So these sums need to be filtered. These sums need to be sorted, but it's not just the sums, it's also these counts that would need to be sorted and the calories that would need to be sorted. So maybe it would be easier to work with this if we just had an array of structs rather than the struct of arrays thing. Struct elf would have, so we would still need this. So this is like calorie storage. So that's the storage, and this would be a slice of that. Calories in sum and the count is in here, like in this slice. And we have an array of these things. Elves. And of course this top 3 sum and max sums, that's actually max sums are not necessary if we're gonna sort them. Yeah, if we're gonna sort them all anyway, then max sums aren't necessary. I might as well sort them here, because we don't need the unsorted version for anything really. Top 3 sum, might as well keep the top 3 sum. Okay. So what does this mean? That means there's only one dynamic array. But if there is only one dynamic, well, actually no, there isn't one. We need to build out an array of elves and an array of calories. There's still 2 dynamic arrays. I mean, one of them technically we could build out just on the arena, right? But whatever. For now, I'm just gonna keep it. So is this like elves, scratch, and well, I mean there is calories, scratch, and then there is elves, scratch. So that's an array of ints. That's an array of elves though. Yeah. So we go in, and then there's the number. Calories get, yeah, so that's fine. This sum gets added. This item count +1. Okay, so this was what happens when we kind of add an elf to the elf array, essentially. Sum scratch. Okay, well, that's not happening anymore. So elf equals what? Well, a slice of calories, right? So like calories. Well, it is a slice of calories, but it's a slice of it'd probably be easier to keep track of like start and end, because we're gonna have to move this array, unless of course we just build it out on the arena. Which is something we can do. Yeah, let's just do that. Let's have a dynamic array of calories. Storage dynamic, let's say. Well, it's not, well, yeah. So that array goes in the arena right away. And we're essentially not allowed to allocate anything else on it for as long as we're building it up. And then the elves array, yeah, we don't know in advance how many elves there are, so that goes into a different arena. That goes onto the scratch. So we could just keep pushing, and then at the end, we just go calories, storage, dynamic. So it's gonna be a slice of that from like items, okay, this item, start to this item. Well, I mean, God, like it's something like item count, start, current item count. It's something like this. So that goes away. So now we've got item count start is 0, current item count is 0, it's not unitary index, item index. Which, aren't we keeping track of that in the lines? Oh no, lines are just counting lines, no, that's different. Alright. Item index, start current item index. So every time we go in through this, so this item count is actually this is a current item index. It gets incremented. And we go in here and we slice. So if there's only one item, let's say, then what happens is we go in here and we slice between 0 and 1, which is what we want. Yeah. So I think that just works. So there is a slice of calories and this sum. So both of these go into, and we don't need to do this sorting at all. We don't need to do either of these. We do need to reset that. We do need to say that item index start is current item index and current. Actually, we do need to say this. So this sum is reset. Current item index doesn't need to change. It's just item index start that needs to change. And this elf needs to go into the elf array. Elves scratch push something like this. Okay, so this calorie scratch is like, it's actually calorie storage dynamic, and the calorie storage dynamic, so that's that. Well, we can't slice it necessarily. Well, we can slice the buffer. Okay. And what happens at the end? Oh my god. Well, at the end, we need to figure out what the size of the array is, because the arena right now is full, but it doesn't actually have to be. So we need to say something like, well, arena arena size used before. Well, I should not use before. Well, no, it is used before, isn't it? Arena used. Alright. And now int, well, I mean, int arena calories size used is calorie storage dynamic arena buff bytes. Okay, so what do we actually have in that? Buffer and length, and pretty much that's it. That's it. Dynamic length times calorie storage dynamic it's the size of the each individual item. So int size of stat. Is it not running? No, it isn't running. Well, it's long. It's fine. What's wrong with this? Well, just call it long. Okay, so now arena used is arena used before plus calories used. Yeah. So just section that off. And now we're free to use the arena. Pretty much. Well, we're free to use the arena to copy the elves. Elves scratch copy arena. Yeah. Okay, now we just set whatever it is we need to set, which is what? Calories storage. Calories storage is calorie storage dynamic buffer 0 to calorie storage dynamic length. Yeah, because it's in the same place. So that's your calorie storage. And then the elves array, well, that's just this. And top 3 sum. Well, I mean, at this point we would need to sort them, right? Somehow. And then top 3 sum would just be elf 0 sum. Okay, so the elves need to be sorted somehow. Well, alright. What's in this? Oh, yeah. Well, I suppose this would be elves. So the first elf should have the highest sum. And then top 3 sum should be whatever it is. Yeah, so max sum 0, that's just elves 0 sum. Okay, well, elf count is elves length. Cast int, what? Are we not gonna have more than 2 million, 2 billion? But is there still a problem? Yeah, okay. because I need to cast it in here as well. Okay, uj, wow. Elves 0 sum. Okay, well, this will be elf. Yeah, we don't really need to slice, it's already a slice. Scale to pixels, elf sum. Okay, what are we, okay, well, top 3 sum, elf length, right. Well, do I need to, like, cast int this, and then also do elf 0 sum, and cast int that? No, actually, that I don't need to cast. Okay, so that should fail at some, yeah, right, that's about right. Yeah. Alright, well, presumably the dstant library should have something for sorting. Let's find out. Function sort. Hopefully it just works, you know? Array dot sort. And you really? And you can pass it. I mean, okay, sure. Sure. Can we just do that? Else sort, like you're gonna have to import, oh my god, you're gonna have to import that, apparently. Well, let's just import it here. Sort, I mean, the way it's done here is like A, B, so like A dot sum greater than B dot sum. Okay, what on earth is this gonna do? Ah, so that throws, of course, why wouldn't it throw? Is there like a sane version of sort that doesn't require throwing exceptions? Boost license. Listed algorithm sorting. Complete sort is sorted, merge, partition, sort, sorts, functions. Okay, well. This is incomprehensible. Like, what are you even writing? Okay, how about what if we just call sort? What happens then? Needs member function op comp for struct elf to compare. Well, see, that we can do. And what does this function return? What does opcomp return? Opcomp. Int. Opcomp returns int. Yeah, so you compare them, it returns an int -1. Yeah, okay. Opcomp. Int opcomp elf right hand side. I mean, honestly, we can just do this, right? It's elf is sum greater than right hand side sum. Like, is that sufficient? Seemingly. What's this error? Opcomp to hash op equals opcast and or to string a non-const. Like, which part is not const? This part? Or const is not a attribute return. Place it after the parameter list to clarify. Like here. And that does something. Presumably. What does that do? dlang const method. Type qualifiers. Const. Okay. Const and immutable. Okay, so I'm specifically talking about not this const. Not this const. This const. Immutable member functions. I guarantee that the object and anything referred to by this reference is immutable. I see. Const member functions. Functions that are not allowed to change any part of the object through this, which is the same as that. Kind of. Okay, so it's just not modifying the object. Yeah, whatever. Whatever. And this, what on earth does this do, though? Let's find out. Okay, so we shouldn't have that many elves. It's just 5. Just the 5. Actually, hold on. Okay. Well, actually, even here. So the arena. Now there's the buffer. There's the used. Okay, so used before is gonna be just 0, right? So now we allocate this dynamic array. We allocate this other dynamic array. Yeah. Then we go through this. Yeah, we don't really care. Run to cursor. No, not run to cursor. Okay. Gallery size used 40. So arena used becomes 40. Yeah, because this is 10. Yeah, that looks about right. Okay, calorie storage, so that's local, so calorie storage, dynamic, and this dynamic, and where is the calorie storage? There, 14 EFB0. Yeah, so that's the same one, and that's in this. Yeah, there it is. Yep. Elves. So elves are now just copy it over, and the first elf calories should be pointing here. Yeah, which seems about right. Okay, elf sort. Oh my god, do we dare step into that? Quick sort. Short sort. Sort 5 pred. Sort 5. Ah, so eventually we do get here. Okay, well, I mean, okay, so I'm convinced that it's sorting. Yeah, we don't actually need to sort the calorie storage, we just need to sort the elves. So what are these elves now? Elves... Footer, elves, length... Okay, well, they're not exactly sorted. Did they change it all? $6,000, $4,000, $11,000, $24,000, $10,000. Oops. No, they're not really changing. Okay, let's do something simpler. Int array like that, temp, well, r, temp r is 12, 7, 8, 21, 23. Temp int temp slice is temp r 0 to temp r length. Temp slice sort. Does it? It can't be returning a new array because I'm not allowed to allocate anything. Yeah, okay, well. Okay, well, temp r, there's temp r, and there's temp slice. Okay, so we call this sort thing. There's temp slice, so sort, and well, it seems to have sorted. So why are my elves not sorting? Temp slice. Why does it invert contrast like that? Temp slice length. Okay, that's sorted. But elves aren't. like the sum is clearly not changing the order of. Yeah, there. It's nothing changed here. Okay, well, what if I do an array of elves? Elf array elf. Can you do this? Yeah, because we're only accessing the sum. Okay, so that should be fine. Elf sum is 7. Elf sum 24. Something like that. Well, okay, so there's the temp array. There's the temp slice. Temp slice 12, 7, 23. Sort. Nothing happened. Nothing happened. Is it because of the weird, like... this is returning true and false, isn't it? God. And we need to return 1, 0, and -1. Let's try that. My God. Oh, there it is. Now it's sorted. So now the elves should sort as well. Yes, except they're sorting backwards. So to sort them the way we want to sort them, we'll just switch these around. Actually, we don't really need the stamp stuff. Breakpoint. Set the breakpoint. Okay, elves. No, I didn't want to step into that. Okay, 24th, there we go. So the top one is now the one. 24, 11, 10, 4, 6, 4. Yeah. Okay, so that seems fine. What? Oh my God. So what? Can we let it run? No. No, we cannot let it run. Is that because we have a test that has less than 3? Yeah, we do, don't we? Less than 3 elves. I mean, we could change the test. We should probably change the test. Actually, what exactly are we testing here, really? But the last one is like... is read incorrectly. Top 3 max sum. Well, now this is times 3. My top max, no wait, this is just 45,000 times 3. Top 3 sum. Elves count is 3. Yeah. Alright. Well, look at that precipitous drop off here. Yeah, that's fine. The only other thing is I probably want, instead of having these gaps between the rectangles, I should probably just make them rectangles with borders. Alright, let's see, where do I define these things? Here, right? Yeah, so this is the actual histogram. It's just this. Histract y, histract x, y, 10, 0. And there's my padding. Int histract width. So there's no padding. But I do want borders. So instead of draw rect, I guess it would be draw draw rect with border. And the color of the border, his border color is gonna be, I suppose, darker, like 75. Draw rect with border UI. His border color. Yeah, and draw rect with border is just gonna be one of these internal functions for now. Void draw rect with border. And what are we taking? Rect and two colors. Mu rect mu color like fill and mu color outline on the border. So that. And internally we're just gonna call mu draw rect like 4 times, 5 times. Mu draw rect, yeah, it's one of these. Rect fill. So that's all we're doing right now. So this should be the same. Yeah, this is the same. Mu rect top is rect top height is 1. Well, I mean, I suppose we should have int border thickness. Mu rect bottom is rect. Well, actually, just top, right? Top bottom x plus equals rect height minus border thickness. Mu rect left is rect, left width is border thickness. Mu rect right is left, right x thickness. Okay, so it's just outline, and this is gonna be top, bottom, left, right. Well, let's see here. Interesting. Do we have too many rects? We have too many rects now. I see. Well, that's not a problem. D3, D11, 1024. Rects capacity. I mean, let's just have that many rects. Yeah, okay, so it is wrong, some of it, but some of it is right. So, right. Which part's wrong? Well, I mean, we can just step through that, presumably, and see. Okay, so rect is that. So top. Well, actually, we can just see it all here. So 323. That's fine. That's fine. That's fine. So the top rects are fine. Bottom rects. X is height minus border. Yeah, bottom rects seem to be same Y. Wait, same Y. So bottom Y should change. Right, left width and right X. Okay, well, that's it. Alright, so we seem to be seeing tops and bottoms. I'm gonna zoom into that. Yeah, seems like we are seeing tops and bottoms. Well, let's see about bottoms. Yeah, alright. I think we're all good here. Okay, well, that is our histogram. Wait, hold on. What happened here? What's with all these? Are they like super small or something? Where are they? Interesting. Oh, wait. We're just not working out the width correctly now because we've removed the gaps between the histograms. Well, we have rect width. And I just didn't use that in the appropriate place. There is no rect pad. Yeah, this is fine. Okay, so well, the only thing that's left with part 1, I think, is to split these into multiple rects. That's just for fun. And we should be able to do that pretty quick. So this is the whole histogram, right? So this is the whole rect. And now we just do for each count elf calories. Okay, so for each count, mu rect calorie rect is hist rect. Okay, so the only thing here is that, so this is the whole rect, and we should like shrink that accordingly. So this count right here is, I guess we can view it as the, can we view it as the height of the rect? Like calorie rect height is scale to pixels count. So that would mean that the whole rect gets shrunk. Towards the top, and for now that's fine. And then we just draw this calorie rect instead of the hist rect. And then we just do calorie rect y plus equals calorie rect height. And we move it down. Well, actually, now scale to pixels, that gives us, when you scale to pixels, that gives us the actual y coordinate of the thing. So what we can do then is we must stack them on top of each other. So when you scale this to count, that gives you the top, the y of the calorie rect. Except we want to add that to the existing y. Calorie rect y, so initially you want to collapse that down to the bottom. So collapse it down to the bottom. Set its height to 0, so that's the initial one. Then for each of these calories that the elf is carrying, we can set the y to, we can add it. Well, we can't actually add it though. We can't actually add it. I mean, we can change the scale to pixels to, instead of scaling to the exact y coordinate, it could do something else. But maybe there is something, maybe, I mean, it's a proportion of this rect, right? So we could just treat it that, like, we have this overall rectangle. That is the initial rectangle. The initial rectangle has sort of a y position, which I guess could be collapsed down. that. And then if you, well, actually, this actually kind of works, right? We set it to that. We set its y to that, and then height, well, yeah, this is kind of a, so when you set the y of the rect, the height is kind of implied by the bounds. Height, get height, oh god, get height, int. Oh, we can even, instead of just getting a height, we can say yeah, we can do something like this. Get this rect. Yeah, because you're gonna have to do it twice, at least. And this rect is just gonna be that. Int y is this, so that's the y of the y position of the rect. So, okay. Well, no, it's both of these actually, yeah, because we need to move the histogram rect to the right. So get this rect. Oh, well, is it? Is it like that though? Maybe it isn't. Like, that's kind of what I want. I mean, so we have this. So for each histogram rect, there's going to be multiple subrects, which is what this loop is doing. So we create one of them, initialize it to be sort of at the bottom, and then we set the y, we set the height to the appropriate amount, which is kind of implied by the y, and then we just say throw rect with border and calorie rect, and then what happens? And then what happens is the y should actually move up, and the height should remain at 0 like that. And then we kind of want to grow it from there. And to do that, so this is the y coordinate. But really what we want is the y coordinate not from this reference, but from yeah, this whole thing. Hold on, let me just put it to do in here. simplify, having to think about all these bounds is not great. All these bounds all at the same time is not great. Okay, so I'm gonna think about simplifying that at some point. Next time. For now, I just want to get this to work though. So this is like int y from base. That's what this y is, right? It's y from base, but we want y from our base. So really, in height from base is y from base minus it's this. So y from base is that, which in this case this just kind of works out, right? This is, yeah, but y from base is that, height from base is that, which honestly, I mean, that is the height. Height, like, that's not gonna change. But y plus equals calorie rect height. I think it's that. So whatever the y is right now, move it up by the height. So we don't do it this here. Well, move it up means subtract. So wherever the y is, move it up by this height. Then draw the rect and set the height to 0, which we don't really have to do because we're gonna have to reset it anyway. Something like that. Int 29. Command list size it's not big enough. Command list size is not big enough. Well, I mean, command list size. Is it in the header? Well, that's clearly not sufficient. Let's have more. Okay. Okay, well, it seems to be kind of doing it. Let's change the colors a little bit. Mu color, calorie rect color, hist color. So we're gonna start there, but then every time through the loop we're gonna increase the red or increase the green or something by 10. And actually use it, presumably, right? Oh my god. So green at the top there, so green. What if we subtract? Now we have blue, dark blue. We can also sort them within the slice. Should probably just do that here. Of course, it's probably not going to sort them in the way that I want them sorted. Let's find out. Elves 0. Elves pointer 0. Okay. Elves pointer 0 calories pointer. This is after the sorting, right? Pointers, pointer 3. 7, 8, 9,000. Well, they already kind of sorted. Although I want them to go in the opposite order, which is probably not going to happen here. So, can we do this? Is that something that's possible? Seven, 8, 9,000. Oops. 9, 8, 7,000. See, that is what I wanted. So the first one should be the greatest one. Alright. Let's let it run. Yeah, so this looks about right, actually. I mean, the colors are, of course, amazing. Okay, there's this. Let's change them a little bit. Just int calorie rect color index. Hist colors calorie rect color index plus equals 1 if well, actually it's just that plus 1 mod what? His colors length. Yeah, so we don't have his colors. Let's have 4 of them or something. I'll just alternate. Okay, well, you're just gonna have to do the ugliest palette. In existence, like that. Gray, cyan, magenta, yellow. No, I mean, they are contrasting with each other. At least, so that's something good, that's good. Okay, well, what colors do we want? Do we want hot pink? Hot pink, hex. FF69 before. Can I get this in RGB? that's beautiful. Look at that. Well, toxic green. Apparently that's toxic green. Yeah. Absolutely, that's what we want, yeah. Well, piss yellow. Just... What if it's just those three? No, wait, it's using something else. What? Oh, it didn't compile, of course. Just, I mean, they are very distinct. So that's good. Is there like a good palette for? I mean, there is kind of an order to these though, because they are sorted. But there is also kind of a lot of them, so yeah. So then, in that sense, they don't really have an order. Let's see. Can we look up like something like qualitative color palette? Optimal qualitative color palettes. Normal, 6 colors. Blue, yellow, red, light blue, pink, green, gray. Normal, 12 colors. Bright, 6 colors. Dark, 6 colors. Yeah, I mean, why not? Let's try it. Green. Blue. My God. Brown. Oh my God, what? IY. Pink. It was 6, right? 6. Pink. Orient. Cola. Is this... One, two, three, 4, 5, 6. Gray. Okay, well, gray for like missing data and stuff. Oh, look at that. Now, well, gray for borders. How's about that? 88. I mean, yeah, that's what works. I mean, they have very distinct, so you can see the different tracks very easily. Okay, well, other than the simplification of this code, which I'm gonna do next time, I think this is it for part 1. I mean, there isn't that much code. Like, this is the part where I thought maybe we should simplify it. There is not much code here. And all of it is kind of localized to just this function. So maybe this is the wrong approach to begin with. Like, I mean, it is what it is. Maybe this is fine. It's just how it's gonna be. Where's scale to pixels again? Scale to pixels is in here. Somewhere there. Yeah. I mean, honestly, compared to the amount of code you would write, like, this is where the histogram starts, pretty much. Well, here is where the histogram starts. It's not even that much more code that you would write for a histogram like that. I mean, it is a lot more, technically, but... Well, I mean, if you account for the fact that we can scroll the histogram independently from scrolling the scale, it's not a huge amount more code than you would write for in like Python or something. So like looking at it, there isn't anything obvious that I would simplify. I mean, of course you can like build out a plot in a separate coordinate system and then translate everything to the pixels, the pixel grid. That would be strictly more code than what I have here. So like maybe it's not worth it. Maybe simplifying it would actually not simplify it. It would just make it more complicated. So I reckon I'll just leave it like this, and then if there is anything I want to reuse for part 2 or 3, then I'll think about pulling that out and simplifying it. So go focus. Yeah, just more acts, yeah. Remove the font from here. Oh yeah, change this data layout. Tests. Let's put a link to the from here. And then just change some tests. Yeah. Yeah, okay, well, why did I change the micro UI? Just the style? And then here, command list size. So this is on the stack somewhere, right? Yeah. So just in the executable. I'll let it stay there. Let's say finish part 1 histogram. Well, day 1, I guess. Okay, well that's it for today. See you later.